In this example, we have two functions f and g, and we need to find the composition f circle g and its domain. By definition, the composition f circle g at x is the f of g of x, because g of x is defined to be 2 over x. I need to compute the value of function at 2 over x. And how is the value of function at 2 over x computed? You just need to substitute every x in the formula for f of x with 2 over x. So we'll have 2. Instead of x, we'll put 2 over x plus 3 over 2 over x goes in place of x minus 4. This expression has to be simplified because we have fractions in numerator and the denominator, and this is not allowed. So first we'll remove the parentheses. It's going to be 4 over x plus 3 over 2 over x minus 4. To eliminate the small fractions in numerator and the denominator, the easiest way is to multiply every single term in numerator and the denominator by the common denominator, which is x. This will guarantee that denominators will cancel, and as a result we'll get the simplified formula 4 plus 3x over 2 minus 4x. This is the formula for the function f circle g. Now, as for the domain of the function f circle g, let's recall the domain of the composition consists of those x's that are in the domain of g, of the first function acting on x, and those x's for which g of x is in the domain of f. So before we'll focus on the composition f circle g, let's determine the domains of the function g and f. Both functions have the variable in the denominator, and therefore we have to guarantee that the denominator is not 0. So domain of g is the set of all x's different than 0, and domain of f is the set of all x's that are not 4. Therefore, if I'm looking at the domain of the composition, if x is to be in the domain of g, x has to be different than 0. Now I have here a case that I want this to be simultaneously true with the fact that g of x is in the domain of f. So this means that 2 over x, which is g of x, has to be in the domain of f. And that simply means that 2 over x cannot be equal 4. Separately, I will find the values of x for which 2 over x is exactly equal 4. Multiplying by x will give me 2 equal 4x, and x is equal to over 4 or 1/2. And therefore 2 over x is not equal 4 when x is not equal 1/2. So those two conditions have to be satisfied at the same time, and therefore domain of f circle g is the set of all the x's such that x is not 0 and not 1/2.